So 13.3 is a big lesson. This is really like the big idea of what we do with trig here in this lesson. It is some review, not only of last year, but it is really kind of putting together lessons 1 and 2. So the stuff that we've been learning in the past couple lessons is all kind of going to come together here in this lesson. We're not going to complete the entire lesson today. So if you look and you're like, whoa, this is a long lesson. It is. We're not going to get through it all today. So then you won't have homework due tomorrow. I'll give you what number you could do through so that if you want to avoid having to do all of your homework tomorrow night, you could do some of it tonight, depending on what your nights look like. If tonight you're a lot more free than tomorrow night, it's going to be a big assignment to do tomorrow night. So, our first type of problem. Let the point 3, -4 be a point on the terminal side of an angle theta in standard position. Okay, there's a lot of jargon in this sentence. We learned yesterday about graphing angles in standard position, and we learned that one side is the positive x-axis, and then we learned that we rotate around to find the other side. This one doesn't tell us an angle in terms of degrees for how to rotate around, but it tells us where a point is. So I want to find that point at 3, -4, and it says that point makes the other side. So we're going to connect that point to the origin, and that creates our angle. Then what we want to do is make a triangle out of this. I'm going to take that point and connect it to the origin and connect it to the x-axis to make a triangle. Always connect to the x-axis, never the y-axis. Then I can label some sides of this triangle. I know I went over 3, and I know I went down 4. Then we can find that third side of the triangle, which is 5. If you learn to recognize that Pythagorean triple of 3, 4, 5, it's a time saver. If not, you can always solve it with the Pythagorean theorem. 3 squared plus -4 squared equals c squared. 9 plus 16 is c squared. And 25 gives 5. Hypotenuse is always positive no matter what direction it looks like it's going. The other two sides of the triangle can be negative depending on direction. So down is a negative direction. Left is a negative direction. Hypotenuse is always positive regardless of direction. Then this question asks us, to find the 6 trig functions of theta. So theta is going to be our angle that is next to the origin, always. Theta is always our angle next to the origin. So then labeling according to that angle, -4 is the opposite, 3 is the adjacent, and 5 is the hypotenuse. So then we can find our 6 trig functions according to SOHCAHTOA. So sine is opposite over hypotenuse, or -4 over 5. Cosine of theta is adjacent over hypotenuse, or 3 over 5. Tangent of theta is opposite over adjacent, or -4 over 3. Cosecant flips over sine. Secant flips over cosine. And cotangent flips over tangent. So this lesson combines some ideas from lessons 1 and 2. So in lesson 1, we talked about SOHCAHTOA. We talked about Pythagorean theorem. And in lesson 2, we talked about how to graph angles. So we're kind of putting those ideas together here, graphing an angle instead of being given a triangle, coming up with the third side, and then doing SOHCAHTOA and the reciprocals on it. Questions? Go ahead and try this one. Okay, so apparently your sheet says positive 12 and mine said negative 12, so we'll just go with positive 12 since that's what your sheet says. So I begin by plotting that point. Negative 5 and positive 12 makes 1 point. A lot of students want to put the point on each axis, like negative 5 on the x-axis and then 12 on the y-axis, and make a triangle out of that. We're plotting that point at the position of negative 5, 12, and then making a triangle with that 1 point. So connect that point to the origin and to the x-axis. Always connect to the x-axis. Then label our sides. We have a side of negative 5. We have a side of positive 12. And to find the third side of this triangle, we would do our Pythagorean theorem. So it'd be 12 squared plus negative 5 squared equals c squared. 144. Negative 5 squared is still positive 25. Whenever you square something, it's always going to become positive. And so then that gives 169, which gives this third side is 13. 5, 12, 13 is another common set of numbers that we use in right triangles. Our angle theta is next to the origin. So for that, then 12 is the opposite. Negative 5 is the adjacent. And 13 is the hypotenuse. So then sine of theta is opposite 12 over hypotenuse 13. Cosine of theta is adjacent negative 5 over hypotenuse 13. And tangent of theta is opposite 12 over adjacent negative 5. Cosecant flips over sine. Secant flips over cosine. And cotangent flips over tangent.
So the angle that usually the opposite of is always the one right next to the x-axis?
Yes, we always want to use the one that's next to the origin and the x-axis. As in lesson 13.1, sometimes the Pythagorean triple numbers don't work out as nicely, so these both turned out to be really nice numbers, 3, 4, 5, and 5, 12, 13. But as in the homework from lesson 1, sometimes they won't. So we're not going to use decimals on that third side of the triangle, but simplify square roots. Okay, so do the same format of your answers just like we did in the earlier lessons. Simplify square roots, reduce fractions when possible, but no decimals. All right, so next we're going to label our axis angles around the picture. So we talked about graphing angles yesterday and said that we always start at our positive x-axis, which would mean this is our 0 line. So then if I would go up around a quarter of a circle, I would be at 90. Halfway around would put me at 180. 3/4 would put me at 270. And if I go all the way around, I've gone 360 degrees. We also learned yesterday how to measure angles in radians. So 0 radians is still going nowhere. So that would still be 0 in radians. And what did we say a full circle was in radians? 2 pi. So then halfway around a circle in radians would be what? Pi. So if the whole circle is 2 pi, halfway around would be a pi. And then if I look at the top of this circle, what comes right in the middle of 0 and pi? A half of pi. And we write it as pi over 2. And what comes exactly halfway between 1 pi and 2 pi? 1.5 pi. And we write it as an improper fraction of 3 pi over 2. Okay, so those are our angles in both degrees and radians as we move around our circle. Then we are going to make a circle. We're going to say that circle has a radius of 1, and we're going to label the places that circle intersects these axis lines. So x comma y, on this first point we would be at x is 1, y is 0. Up at the top would be x is 0, y is 1. Over the side, x is negative 1, y is 0. And down at the bottom, x is 0, y is negative 1. So in the last type of problem, I gave you a point and you plotted it, and you can make a triangle out of it. If I would give you a point that would lay on an axis line, you can't make a triangle out of that because you would connect it to the origin, and then that would be all you could do with it. You couldn't make a triangle from that point. So then we need to use what's called the unit circle here. It's called the unit circle because we're going to say that its radius is 1 unit long. Okay? So that gives us all ones around our circle here, ones and zeros. This helps us find trig because each of these points on the circle is alphabetical cosine, comma, sine. Just like alphabetical x, y, alphabetical cosine, sine. Tangent is sine divided by cosine. This picture and information is something that you should be able to recreate on your own. I don't like using the word memorize, but I mean, I guess in a sense that's what you need to do with it. You need to be able to recreate this circle to be able to solve problems with it for the upcoming quiz. So what we do with this information then is I would ask for the trig functions of a specific angle that's going to be somewhere right on one of these axis lines. And so that's what our next problem asks us to do, is to find the 6 trig functions for 180 degrees. So then what I want to do is I'm going to recreate my picture here since I lost it, but you don't have to since you still have it. I'm going to think about where 180 is. And in my circle, that point on the 180 line was the -1, 0 point. That's the only point I care about for this question because that's the point that's on the angle line that I was asked about. I was asked about 180. That's the point on the 180 line. So that's the only point that I care about for this problem. That point and all of the others on the circle are cosine, comma, sine, and tangent is sine divided by cosine. That information will allow us to find our 6 trig functions. So if that point is cosine, comma, sine, then the sine value is the second part of that point, or the sine value is 0. Cosine, comma, sine, so cosine is the first part of the point, so the cosine value is -1. Tangent is sine divided by cosine, so that'd be 0 divided by -1, which is 0. So the sine and cosine come directly from the point that's on that line. Alphabetically, cosine is the first part of the point, sine is the second part of the point. Then tangent is the sine value divided by the cosine value. For the reciprocals, I'm going to do cotangent first. A reciprocal flips over a fraction. So if I flip over that fraction, I would have -1 over 0, which is impossible. We are not allowed to divide by 0. That's the biggest no-no in math. So we say that is undefined. 0 on the bottom of a fraction is undefined. 0 on the top is fine. 0 on the top is 0. 0 on the bottom is undefined.
Yeah. What is the cosine, comma, sine? Like, what does that do?
That tells us which parts of this point, so that point I labeled -1, 0, that tells us which parts of that point are which trig function. That cosine is the value of -1, and sine is the value of 0. Cosine is the first part of the point, and sine is the second part of the point. So then for flipping over the other ones, we can make anything into a fraction, even if it's not. So for sine, it was 0, but I could say it was 0 over 1. And if I flip that over, I get 1 over 0, which is a problem, undefined. I can make that -1 into a fraction by just dividing it by 1, and then I get 1 over -1, which is still just -1. When you do reciprocals, Ones or negative ones will stay ones or negative ones. Okay? Zeros and undefineds will flip-flop. So if it's a 0, it'll become undefined. If it's undefined, it'll become a 0. Okay. We're going to do another example on this together. This one gives our angle in radians. So we'd want to locate where in that picture was pi over 2, and pi over 2 was up at the top at the 90 line. And that point on the circle is 0, 1, which is again alphabetical, cosine comma sine, and tangent is equal to sine over cosine. So then I have all the information I need to find all 6 trig functions. So sine is the second part of the point, so that is 1. Cosine is the first part of the point, so that's 0. Tangent is sine divided by cosine, so 1 divided by 0, which is undefined. Then when we do our reciprocals, flipping over a 1 or a negative 1 will not change it. So cosecant is still 1. Flipping over a 0 or an undefined will make it be the other one. So for secant, we will have undefined. And for cotangent, we will have 0. Questions? I want to give you one to try. Find the 6 trig functions for 270. Alright, so for 270, I recreated the part of the circle that would use 270. 270 is the angle down at the bottom. That point was over 0 and down 1. And that point, along with all the other ones on the circle, give us alphabetically the cosine and then the sine. And tangent is sine divided by cosine. So then using that point, I can fill in the 6 trig functions. So sine is the second part of the point, so sine is negative 1. Cosine is the first part of the point, so cosine is 0. Tangent is sine divided by cosine, so negative 1 divided by 0, which is undefined. Cosecant flips over the sign. When you flip over a 1 or a negative 1, it will not change its value. Secant flips over cosine. When you flip over a 0, it will become undefined because that will create dividing by 0, which is a no-no. And when you flip over an undefined, it will become a 0 because that will fix the 0 from being on the bottom and put it on the top, which is not a problem. Okay, so zeros and undefineds are going to flip-flop. Ones or negative ones will stay what they are. Questions? The last thing we're going to talk about today is a reference angle. We've actually already done reference angles, so this really isn't anything new. We're just defining the term that goes along with it. A reference angle, it says, is an acute angle that corresponds to a given angle. There are 3 characteristics of a reference angle. A reference angle will always be acute, it will always be positive, and it will always be next to the x-axis. So when asked to find a reference angle, what we are going to do is graph the given angle. So 320 degrees we want to graph. We learned about graphing angles yesterday. So we start at that positive x-axis. I want to go around 320 degrees. We learned that we go around counterclockwise. And going around 320 would leave me 40 short of a full circle. 40 is the reference angle. So that number that I was telling you to put into your drawings yesterday, that's the reference angle. It should always be positive. It should always be acute, so it should be smaller than 90. and it should always be next to the x-axis. So that's why I said yesterday some students want to put it in the other part and say that this is like 50 past 270, which is true, but not helpful because our reference angle should always be next to our x-axis. Okay, so it's positive, it's acute, and it's next to the x-axis, next to the closest horizontal. So 40 degrees would be the reference angle there. One thing we didn't talk about yesterday was how to graph in radians. To graph in radians instead of converting, there are pi radians in half of a circle. Okay, 2 pi is a whole circle, 1 pi is half of a circle. Our question asks us to think about pi divided by 6. So what we're going to do is divide up that pi, that half of a circle, into 6 pieces. So I have 6 pieces on the top half of the circle. I am also going to divide the bottom into 6 pieces. Okay. So the denominator tells you how many cuts to make. We want 6 pieces in each half of the circle because pi is half of a circle. We're cutting each pi or each half into 6 pieces. The numerator then tells you how many of those pieces to go. I want to go -5 of those pieces. So we start at the same place we always start at, the positive x-axis, and I'm going to go backwards 5 pieces of the circle. 1, 2, 3, 4, 5 pieces of the circle. Our reference angle is how big that angle is, because that's the one that's next to the x-axis. How big is that angle? 30, because we divided half of the circle, or 180, into 6 pieces. 180 divided by 6 is 30, so each of those pieces was 30 degrees. The bottom tells you how many pieces to cut each half into. The top tells you how many pieces to go around. And then our reference angle is whatever's left next to the x-axis.
So you just divide 360 by the amount of pieces?
You could divide the whole 360 by 12, or you could divide up 180 by 6. Either way, it'll work out the same. So for this one, to graph in degrees, we're going to start at our positive x-axis. 140, I'm going to go around counterclockwise. And what's my reference angle?
40.
40, because I'm 40 degrees before the x-axis of 180. For radians, cut each half of the circle into the denominator number of pieces. So I want each half of the circle to have 4 pieces. Means the whole circle has 8 pieces. And the top tells you how many pieces to go. I want to go -3 of those pieces. So I'm going to go around clockwise 3 pieces, which leaves me with that piece. And how big is that piece? 45, because 180 divided by 4. I'm going to look at one more graphing in radians example. We're going to graph 2 pi over 3. You will usually be graphing in radians with a denominator of 6, a denominator of 4, or a denominator of 3, because those create some special angles for us, and we'll get into that more tomorrow. You could do anything. They could ask you to cut it into 7 pieces. That's fine. You can do it. Just the degrees don't work out as nicely. Dividing by 6, 4, or 3 works out nicely. To cut each half of the circle into 3 pieces, I actually don't want to draw my y-axis, because it gets in the way. So if I want each of those 3 pieces to be equal pieces, the vertical doesn't work for cutting into 3 pieces. So when you cut into thirds, just don't even draw your y-axis. Then if I want to go around 2 of those pieces, I start at my positive x-axis and go around 2 pieces. Leaves me with 1 piece. That's how big? 60. Okay. That is where we are going to end our lesson for today. Your homework is not due tomorrow. But if you would like to get a jump on it, since it is going to be a little bit longer of an assignment, and I don't know how busy you will be tomorrow night, with what we have learned, you could do through number 42.
Wait, how come
Ours
it's
has a
different?
different.
Yeah.
Oh,
Ours says
yeah,
27, 28.
yeah. Do what yours says, but you could still go through number 42.